Hello and welcome to this lecture in the course for Secure Systems Engineering. In the previous lectures and the lectures that we have seen so far, we were constrained to executables. We had looked at how vulnerabilities in the executable can be used to create different exploits. In this lecture and the lectures that follow, we'll be looking at access control mechanisms. So for any system to be designed to be secure, we would have to ensure some access control policies. Essentially, for any secure systems, there are three specific goals. It's known as the CINA: confidentiality, integrity, and availability. So the access control is used to obtain the confidentiality and the integrity aspects of a secure system. So in this particular lecture, we will be looking at fundamentals about what access control is and how it can be implemented at different levels. At a very high level, access control defines who can access what. The who over here are the subjects and what are the objects. And access is defined as various operations that these subjects can perform on these objects. For example, subjects can be a user or a process or an application, while objects can be files, programs, sockets, or hardware. And access could be read, write, execute, or share. So, for example, access control can define if a user can read, write, or execute a particular file, program, or a socket in the system. So access controls are available in a number of levels in the system. So you have access control policies which are present at the hardware, operating system, middleware like DBMS, and also in various applications. So as we go upwards from the hardware towards the application, the access control mechanisms become more and more complex. So in hardware, for example, a simple access control mechanism to prevent, say, reading or writing from one memory location would require far less amounts of overheads and far more simple compared to the access control mechanisms that are implemented in the hardware. So as we move from the hardware to the application, there are more aspects and more finer aspects to be controlled. So the complexity increases in the same way, and also the reliability and the guarantees that can be provided by the access control is more difficult to achieve. So essentially, access control mechanisms provided in the application or middleware are more prone to loopholes and can be exploited. On the other hand, finding a loophole or a problem or a vulnerability in the hardware is far more difficult. So what we will be seeing in this particular lecture is some of the hardware level access control mechanisms and also the OS level access control mechanisms. So we will start with the hardware access control. So the policies with which hardware access control are built are these. First, the hardware should ensure that the operating system is protected from the applications. Second, it should have techniques and policies to ensure that one application cannot interfere with another application. Third, there should be policies to ensure that one application does not hog the entire system. So these two things, the first and the second, would ensure confidentiality and the integrity. So for example, the hardware provides mechanisms by which the applications cannot modify or view the OS executable and the OS code. On the other hand, the third mechanism, which is provided by the hardware, ensures availability. So it will ensure that one application does not utilize the entire hardware all the time. So in order to achieve these three objectives, what is implemented in hardware are the mechanisms. So we have paging units, privilege rings, and interrupts. So the paging unit would be able to isolate one application address space from another application, and thus using the paging unit we would be able to protect one application from the other. There is also the privilege rings. So privilege rings in Intel x86, there are privilege rings 0, 1, 2 and 3. So these rings would achieve protection of the operating system from applications. So for example, in x86, the operating system runs in ring 0 and the applications run in ring 3. The hardware takes care of the fact that applications in ring 3 cannot directly read or write to any application running in ring 0. Since the OS runs in ring 0, therefore it is completely isolated from the user level applications which are running in ring 3. So the third mechanism is known as interrupts. So interrupts are used to achieve this particular policy, where it can be used to prevent one application from hogging the system. So the interrupts can be used by schedulers to obtain context switching. So when an interrupt occurs, the scheduler can pick a process and preempting the existing process, thus achieving the fact that one application is not hogging the entire system. Now at the OS level, there are several more different types of policies. Some of these policies are implemented with the help of the hardware, while some are very specific to the operating system. So some of the access control policies supported by a typical operating system are as follows. One particular policy is to ensure that only authenticated users should be able to access the system. So as we know, in order to implement this, we have mechanisms such as the login and password checking, and only if users have a valid password, only then would they be able to access the system. So this particular policy is achieved by user authentication. Another aspect which many operating systems support is to ensure that one user's file should be protected from the other users. So the prior operating systems such as MS-DOS and older versions of Windows do not support this particular feature. However, in most modern operating systems, we have access control mechanisms for files which would permit users to actually set privileges and various access control policies like read, write and execute to ensure who can read their files, who can write or modify their files, and who can execute their corresponding programs. In addition to the file system and user authentication type of access control mechanisms, operating systems along with the hardware also plays a role in protecting one process's memory from other processes. So essentially this is done by the page table mechanisms. While the operating system creates these page tables and configures the hardware to manage these page tables, it is the hardware which actually ensures the isolation between the various pages, and also ensures that the access control policies such as read, write and execute to a particular page is verified at runtime. Another access control policy which typical OSs implement is the fair allocation of resources such as CPU, disk, RAM and network, so that one process is not starved of a particular resource. In order to implement this particular access control policy, various mechanisms such as scheduling, deadlock detection and prevention are used in order to prevent starvation of a particular process and ensure that all resources are optimally shared amongst the various processes in the system. So we will look at one of the most common access control mechanism for the operating system. This is known as the discretionary access control, or DAC. In the DAC access control policies, the access is based on the identity of a requester. There are some access rules that are defined, and based on the identity of the requester, these rules are verified, and only if the verification passes, only then will this requester, which is the subject, would get access to the corresponding object. So in a typical Unix-like operating system, all of these privileges of who can access what is typically managed by the administrator. So the administrator, such as the root user of the particular Linux or Unix system, can decide what privileges can be granted or revoked. Users would be able to pass on privileges from one user to another. So we will look at one of the earliest forms, which is known as the access matrix model. So the access matrix model looks like this. So it was proposed by Butler Lamson in 1971, where he had defined subjects and objects. So essentially, subjects are the active elements in the system which request to have access to specific objects. Objects, on the other hand, are passive elements and used to store information. So they could be like files or programs or any other thing. So for example, a program can be an object, and you could have access control policies to determine who can run that particular program. At the same time, a subject can be a process, and you could have access control mechanisms for that particular process to determine what files that process can access, what other programs that file can execute, and so on. So the entire access matrix model is represented as a matrix like this. On each row corresponds to a different subject. For example, over here we have 3 subjects, Anne, Bob, and Carl, while the columns, on the other hand, represent objects. So we have objects file 1, file 2, file 3, and a particular program. Now corresponding to each cell in the matrix is the various rights for what that subject has on that particular object. So for example, over here, Anne is the subject and file 1 is the object. Anne can read, so Anne is the owner of this file 1, and therefore Anne can read and write to file 1. On the other hand, Bob can only read to file 1. Bob is not the owner, and Bob cannot write to the file 1. A more formal representation of this access matrix is shown over here, where we define the access matrix as a matrix A comprising of subjects and objects. Further, we have generic rights which are present. So this is defined by the set R comprising of various different rights. So here we show K different rights, R1 to Rk. And we have some primitive operations which is defined by the set O. So these operations, there are 6 of them, which would define what operations can be performed on this particular matrix. For example, you can enter a write R into a particular cell A of xsi, comma A of xoj. For example, I can enter a write to read in a particular cell such as this. Similarly, you can delete a write from a particular cell, create subject, create object, destroy subject, and destroy object. Now, based on this formal mechanism, we can define commands. So this commands is what is used to specify the access control for that particular system. A typical command would look something like this. So you have a command alpha, and unless certain rights are available, only then can certain operations be performed. So we will take a few examples of this. For example, we have this create command. So this create command takes a process and a file, and the command is as follows. So create object file and enter own into process comma file. In this way, what we see is that a process can create a file, which would mean that in the cell corresponding to this process and this file, the ownership attribute gets added on. Similarly, this is another example of confer write. So in order to run this command, we first check if the owner is in fact the owner of the file. This is checked by looking into the access matrix corresponding to owner and file and determining whether own is present in that particular cell. If the own is present, then you have the right to add R into that friend's entry. So another example is this confer write, where you can confer write R to a friend for a particular object. So in this particular example, we show how someone can confer a particular write R for a file to a friend. So the first thing to do is to check whether the owner of the file is the right owner. We do this by looking at the access matrix and noting whether own is present in that particular cell corresponding to owner and file. And if this is true, then we can add the write R into friend comma file, into the cell corresponding to friend comma file. This is another example of a command which is to remove a write from an ex friend for a particular object, in this case a file. So what we check over here is that only the owner can remove the write from a particular subject for a particular file. So only if the owner is the rightful owner of the file, only then this particular command will succeed. So what we see over here is based on this definition of the subject, object, the access matrix, and the various primitive operations. One could create various different types of commands. So these commands define the access control policies for that corresponding operating system. This access matrix would be the basic building block for creating your access control policies for your operating system. Therefore, we could have two operating systems using the same mechanism. Based on these commands, what we see is that the operating system can define how various subjects can have access to the various objects present in that system. So in practice, it is not a very optimal way to implement this access matrix model. This is because quite often the number of subjects and objects are quite large, and the matrix that we obtain is highly sparse. And therefore, a more practical implementation is by using capabilities or access control lists. In a capability based system, what we have is that we have one user and we have the capabilities of that users. So we have a user, and this user owns a list of all the different capabilities that he or she possesses. So for example, over here, Anne has a list of all the capabilities. Anne has the read and write capability for file 1 and is also the owner for file 1. She has the read and write capability for file 2 and only the execute capability for program 1. Right? On the other hand, the access control list is exactly the opposite. Here we maintain a linked list for each object. So for example, file 1 can be read and written to by Anne, and Anne is also the owner of this file 1, and Bob can only read the file. He does not have any other permission for this particular file. Capabilities versus access control lists have their own advantages and disadvantages. For example, if you want to delegate your rights to somebody else, then a capability based model is much more easy. So let us say, for example, in an office environment, Anne is going on a vacation and she wants to delegate all her tasks to somebody else called Ted for some time. So for example, she wants to delegate all her jobs to Ted from 4 p.m. to 10 p.m. So what she does is that she can create a certificate stating that she delegates all her jobs to Ted. Therefore, from 4 p.m. to 10 p.m., Ted has complete access of all her capabilities. So what is required is Ted having just this particular ticket, which gives him right to all of Anne's files. If we want to achieve the same kind of delegation with the ACL, that is the access control list, then it is far more difficult. The reason being, so in this case, Anne has to pass through every object that is present in the system, and just for a period of 4 p.m. to 10 p.m., she has to add permissions for TED to ensure delegation. So this is far more difficult than just creating a certificate which gives TED the permission to access all of Anne's files from a particular period to a particular period. Another widely used functionality is that of revocation. In revocation, access control lists are much more efficient than the capability-based model. During revocation, it is easily done in ACL because all that is required is to parse the ACL list for a particular object and remove the user or the subject from that particular list. However, if we want to actually do this using the capability based model, this could get a little bit tricky, especially if you have one capability that is used to service multiple files. And what we want is for that particular subject to access all the files except one. So this is very difficult to do with the capability based model. So in this lecture, we had actually looked at access control policies. We have seen how access control policies are implemented in the hardware, and a very primitive form of discretionary access control, which is implemented in many of the operating systems. In the next lecture, we will look at how this access control policies are implemented in Unix or Linux type systems, and we would also look at what is the major drawback of having a discretionary access control policy mechanisms, and we will actually see how this could be made better by something known as a flow control policies. Thank you.